All right, I guess we should go ahead and get started maybe? I know we only have 25 minutes. Well, hi everybody. I'm Kathy Spence and I'm from Intel. And I'm here to talk to you today about the transparent supply chain. The transparent supply chain is a project that we've been incubating at Intel, and we're thinking about where we want to go forward with it. And so what I'm looking to do with you today is talk a little bit about what this project is and what problem it solves, and get your feedback on whether this would have potential as an open project, and whether folks are interested in maybe participating in that. So we're really looking forward to having some feedback on this. So I'm going to talk about the fact that supply chain security and visibility into the individual components that make up the platform. This is an area that is really increasing in importance. A lot of folks are concerned about supply chain attacks right now. So we'll talk about that. And also, the work that we've done at Intel around our transparent supply chain project. We've actually have it in limited production already. So we'll talk about that. What does that look like and what does it do and what problems are we trying to address? And then let's spend a little bit of time thinking about the vision, our vision around device lifecycle transparency, which includes that industry-wide type of collaboration. Okay, and so just first, just wanted to point out, Intel, we take corporate responsibility very, very seriously, and that's really where this project came out of. And you'll notice in the bottom right-hand side, where it's where we have a very, very strong focus on our own supply chain for manufacturing our own components as well, and we have our security first pledge. So these are things that are super important to Intel, and so that's why we've been working on this. And around the supply chain, there are just growing concerns from an industry standpoint. It seems like every day there are new reports in the media of some other supply chain concern. And then also that's driving some policy and standards. And also the trade wars are making it even worse, right? And having a deep understanding of where all of the components come from, the provenance of those components, along with these policies and standards that are emerging. This is creating more focus on the supply chain. So, and what you'll notice there in terms of driving some of those policies and standards, you'll notice that there's a particular Federal Acquisition Supply Chain Security Act and a DFARS, that's called the DFARS regulation, into providing 2 levels of transparency into the platform. So understanding that the platform itself is authentic, and then the next level down in terms of components is also authentic. All right, and that's for both, from a counterfeit perspective, right, which is more of like a quality, you want to know for quality purposes, but then there's also malicious components, so there's a security aspect as well. Okay, so this is our device lifecycle transparency vision, and really it starts really when the device is born, actually before the device is even born, right? So back at component sourcing, right? So here at component sourcing, we really want to understand, what's composed, how is that component composed, right? What's in each component, and then at the time that the platform is built, which components are actually part of the device, right? And then as it traverses a distribution chain, right, we want to know, does that device arrive in the right state as it was built, right? And then over the life cycle of the device, as you go to operate the device, after you've provisioned it, how is that device changed? Does it have the same hardware in it, or does it have different hardware in it? And then also, is the device up to date and healthy, right? And so here again, it's hardware, but it's also the firmware and the software on the device. And then at the end of the day, when you retire it, you want to understand whether or not it's got the same components in it as you would expect it to have, right? So it's really through that entire life cycle. And then through this, there are ownership transitions. So really understanding who is the rightful owner of that particular device. So when the device is first born, the OEM owns it, right? When it may go through the supply chain, and others may kind of temporarily own it until it gets to its first real owner who's going to provision it and use it. And then of course there could be additional owners even after that. So understanding all of this together, so this whole life cycle, so this is really like compute life cycle assurance, really kind of understanding that entire life cycle of the device is part of our vision. Okay, so let me talk about what's in limited production today. So today we are capturing really telemetry about the device as the device is being born, right? So here we're capturing information right at the time that we are building the platform. And that's composed of component data. It includes a platform snapshot and includes information that we need to generate a TCG standard certificate that can be used to attest the authenticity of the platform. So we're capturing all of that at the ODM. And then we're sending all of that information up to Intel, where we're signing it in our key generation facility, which we sign a lot of content there. And we generate all of the Intel keys there as well. So we're signing this transparent supply chain data there. And then we're storing that information. We're creating the certificates as well as signing that bill of materials type data, and then making that available for download so that when you buy your device, you can go download the data that's associated with your device. And then we have a little tool that comes with it called Auto Verify tool, which you can use to do some reporting. So that's really how it works today. I'm going to go a click deeper and show you some of the data that we're capturing today so you can get an idea of what that data looks like. Right? So today, for component data, we're capturing 24 different fields of data, right? And really about the major components of the device, especially the active components, right? And so here, here's a list of the components that we're capturing today, and we're capturing 24 different fields associated with that. And so this is just a sampling of some of the data. So basically, this is, where did those components come from? Who manufactured it? Where was it manufactured? What date was it manufactured? What was the batch number of it, and so forth. All of that manufacturing data for each different component. Then we're also capturing a platform snapshot, right? Where here we're capturing the EK serial number for the TPM, as well as some PCR data and some additional information. This is a platform snapshot that we're going to use as part of our Auto Verify. Information that comes directly from the platform that's going to help us understand some of the changes over time. So some of this other data over here, it can't be generated from the platform. We're just capturing it at time of manufacturing. And then over here we have certificate data. So this is just for convenience that we're putting this in a separate file that makes it easier for us to go ahead and process and generate just a standard certificate according to the TCG spec. So the other thing that you'll notice about this data is that, especially over here, the list of the components, right? I work in the client computing group, but for Intel, this is actually a project that goes across client, server, and IoT devices, as well as some components as well, as part of our own manufacturing process. So this is, so you'll notice this data here reflects that. And the other thing that you'll notice here is that we're capturing some information from the shop floor control system, whereas other information comes directly from the platform, right? And so, and as we generate, as we capture all of this data and we sign it, we're cryptographically linking it to the device using the TPM as the identity for the platform, okay? Okay, so as I said before, we're doing this today. It is in limited production where you can actually purchase this. So you can actually buy a device from Lenovo that has transparent supply chain data associated with it, right? And we're in the process of it expanding across more Intel platforms and working with more ODMs. We have a number of ODMs that we're working with today and several OEMs. Also, what we plan to do is to link it to the Intel manufacturing traceability. So some of the work that we do around our own supply chain, as we manufacture our own components, there's a big traceability program that we're going to start to link that up to what we have with the transparent supply chain, so that we have even more data and more transparency as part of that. And then the third strategy that we have is that we really want to evolve to a more shared federated model. And this is where we would like to really start working with the community and with the ecosystem in order to expand. And as we do that, we have a model for what we think that the industry collaboration could look like. And we have a proof of concept that we've already done with a blockchain, as opposed to the very certificate-based solution that we have today, which is really just a first step. We're looking at utilizing blockchain. This is a perfect application for that. And it can really protect a lot of the privacy. So one of the issues that we have with our existing solution is that all the data comes to Intel, and Intel's doing all the signing. So that exposes a lot of data that maybe the OEMs don't want Intel to have. And in this kind of a model, we can run individual nodes in the blockchain, and we can protect some of that data. So in this model, we're using an Ethereum. We're using Ethereum as our blockchain, and we've developed some software that's a dApp for the blockchain, which is basically the software interface for that. And as we run individual nodes there, we have smart contracts in place that can handle the transition of ownership. And provide that interface to be able to upload information into the blockchain. And that can be uploaded into some secure storage, because basically the blockchain is just providing pointers to the data. And so therefore, you can do more with the data. It could be, it could be encrypted, it could be, or just stored somewhere else securely, and just everyone uses the same blockchain, basically. So that will provide privacy. And a lot of work that we're doing right now in terms of the smart contracts and with blockchain is to create more privacy around the data, so that only the current owner can see the data associated with that device. And maybe there's some limited data that the OEM gets because they're providing the warranty services for that particular device. So this is where we're looking at evolving to. Okay. Okay, so why am I here talking to you guys about this is, I'd like to understand whether or not a model like this would be, a successful open project. So we're interested in knowing that, and whether or not there's a good intersection with OCP. Okay, so that's my overview of the transparent supply chain. Does anyone have any questions?
About smart contracts. So you are actually assigning the smart contracts to the specific platforms. So currently, what you control, the visibility of the data, or what type of the?
Yeah. It's a lot of that is for the entitlement around who can see the data and who has, So this is a private blockchain type of a model, and you need to be able to control the access, right, to that blockchain, as one of the sensitivities is if you have a lot of visibility into that data, then you can understand what someone's business model is. You can get there could be unintended consequences there. And so therefore, we need to really protect what's in the blockchain. So the smart contracts are helping us with the transition of ownership, so that we understand who's the correct owner of that particular device. And then once you know who the owner is, right, then you can you could use that information in order to be able to do other things, like maybe authorize changes to the device, or you can use it to like provision owner keys to the device, for example. So there are several use cases as a result of that. But the smart contract is, that's really what the blockchain does, right? In terms of like having that the ledger, and you're basically, in a monetary model, right? The ledger is moving money around. Here we're talking about moving, computing devices around or components around. Does that make sense? Yep. Yes.
We are a partner on the like a new program or new project production. It's not really a release product. How does it apply to us?
How does it apply to you?
Manufacturer?
Well, that's what I'm here. That's what I'm here to look at. Does it make sense to do some work with OCP around understanding the life cycle of the device? We heard about that yesterday, right? And having this information may boost the residual value of the device by understanding, how many owners did it have, and does it have authentic parts or not have authentic parts? This could relate. Also, there's a lot of work going on right now around root of trust and platform root of trust in OCP. And this is something where you may have a root of trust, right? But having the data separate from the blockchain gives you something to compare against, right? For that. Also, it has, by storing the data, the supply chain data in the cloud, you can do more with that data. So one of the use cases for transparent supply chain is, like, let's say I have a fleet of devices, or I have a giant data center, and I found a problem with one of the parts, and I want to know, do I have that part anywhere else in my data center? All of that information is available in the transparent supply chain. So you can think of this as, it's really some telemetry data that has been, harvested and stored in the cloud. So you can use it for multiple purposes. So that's why I'm here too, to find out, are there some applications here within this particular community? If we form a community to go work on this, is this the right community to work with? Or, should we go work with like a supply chain or more security focused kind of community?
We wanted to know how deep of the supply chain tier 1, tier 2 are going to be directly involved.
Right, so we're focused on that DFARS regulation, which is the 2 layers of transparency. We want to be able to prove that the device is authentic and it came from an authentic manufacturer, and then the next level down of the components. Right.
So
Okay.
that was my question, actually.
Mm-hmm.
You're starting from a standard source that will feed into the telemetry, right? So how are you making sure that the first step is trustworthy? When first data that you get it from like ODMs and so on.
Right, so in the current model, we're trusting the manufacturing environment. We're trusting the ODM. Right? And as part of the transparent supply chain, there's a statement of conformance that comes with it. So you understand, basically the policies and procedures under which that particular component or device was created. So that could involve things like purchasing parts from a trusted supplier list, an approved vendors list. It could include things like, having a certain amount of audits per year. There could be other policies and procedures as part of that. Each OEM can make a decision about what's included there. But right now, those policies, between the policies and procedures, and that enables us to help us trust the ODM. If we don't trust the ODM, in the future, we can say we don't trust the OEM, and we can add more to this and kind of step back and and improve the model. Yeah.
Would it be possible if every single component will have its own data,
Mm-hmm.
so then from the original manufacturer, not from the OEM, because right now you have kind of the start is
Yeah.
late.
Yeah,
So
that would be
if
even
you
better.
start earlier, then there is no need to have this additional trust, right? That could be alleviated by having like 100 or 1,000 components, each of them with its own little
Absolutely.
task, and then you can just instantiate the device, and from that point it will be a device. So
Yeah, if you go back in the in that device lifecycle, right, to the actual manufacturing of the component itself, and you took the information around manufacturing of that component and put it in the blockchain, so it's already there, and when you build the device, you can just point to that as opposed to just pulling that information from the shop floor. That's a much better solution. So that's part of our vision there, But today, right, no one has this data today. This is the first of its kind in the world where you can actually buy a device and get all of this data associated with your device. So so consider the work that we've done right now is really a baby step, and just even making some of this information available is a step in the right direction to have that transparency.
So where will the blockchain reside? Is that still at Intel, or
No.
hand things over to different actors?
Right. So this is where we really have to think about, how we form this community. It's a little bit different, right? Because I think a lot of the projects that I've seen in the OCP, people are maybe coding and then putting things in a GitHub, and everyone's getting a copy and everything. But we're asking for more here. We're asking for people to run a node. And contribute as part of the blockchain. So there's some code here as well, right? Because we have that application, that DApp, that does the smart contracts. So, I envision that our community will do some coding. I envision our community will do some governance. And then there will also be certain folks that will run nodes as well. Right, because that's what a blockchain is designed to do, where you have folks that don't necessarily trust each other running different nodes, and then the checks and balances are in the blockchain, right? And then you can't roll that back. That's the value of using a blockchain.
but it's not owned by Intel. The data is in a blockchain.
It's not owned by Intel.
So Intel does not own it even now.
Yeah, and Intel won't have visibility into it either. Right, that's the idea. Okay, so what do you guys think? Do you think that this is an OCP-like project, or do you think it's not?
For the circular economy, it should be.
It has potential.
Yes.
Okay. So if anyone is interested in this, let me know. We're interested in identifying who might want to participate with us. So please let me know, and we'll be looking to see if this is a topic or a sub work group or something for OCP. Yep.
This does not solve the problem of implementing a new device on the platform which will not be disclosed to the host. Like you mentioned.
Yeah, that's true. That's true. Our first implementation, we're very focused on the manufacturing to the first owner. And right now, with our auto verify tool, it's kind of a manage by exception kind of a model. So if you run the auto verify tool and it doesn't match, you can say, oh, it's got a new SSD in it. And I expected that because I needed a bigger SSD, and I put a big SSD in it. And so I'm going to use my current snapshot as my new snapshot. So that's kind of how it works right now. But there's tons of room for improvement there, right? And I would like to see us authorize changes as opposed to waiting for a failure and accepting a new snapshot. Really, the right way to do it would be to authorize those changes. And who can authorize those changes? The current owner. And how do we know who the owner is? Because we're going to track it in the blockchain. And the blockchain model of the ownership is a sign-over process. And I equate it to like a car, like when you own a car, right? So how do you know you're the owner of the car? It's because you have the title to the car, right? And if you sell the car, you sign over your pink slip to the next owner. And that's how, and then they register, right? With the Department of Motor Vehicles, right? That's kind of how that works. So we envision a similar model here, right? Our smart contracts work that way. It's a sign over. I'm the owner, and I'm going to sign it over to you, right? And so we're able to identify who the owner is centrally, and be able to prove. We'll be able to prove who that owner is, and then based on how we register folks with the blockchain, right? We'll be able to prove it. right? So, and then in that case, then you'll be able to capture more of the data, right? You'll be able to capture more of the data, you'll be authorizing those changes, and you'll keep that information in the blockchain more up to date than what we're doing today. Okay, any other questions? All right, well then, thank you for coming.